Welcome back. In this video, we are going to graph rational functions. And I'm going to introduce graphing rational functions by simply plotting points. We're going to choose values for x, we're going to input that into our function, find an output y, and then we'll plot the ordered pairs on the Cartesian plane. But in order to graph a rational function, let's say we want to graph f of x equals x over x minus 2. We want to find the restrictions on the domain. We want to find out which values of x we cannot use. And then we know, of course, we can use all those other values of x. So with a rational expression, we don't want the denominator to be 0. If x minus 2 becomes 0, our fraction is undefined. So first, let's find our restrictions. So we do that by setting our denominator, x minus 2 cannot equal 0. So we know that x cannot equal 2. So 2 is the only invalid input. This is the restriction, and what this will do is this will create a sort of an imaginary line on our graph. We call this line a vertical asymptote. We'll have a line at x equals 2 that our graph will approach but never hit. And we will denote this as a dashed vertical line. And we call that dashed vertical line an asymptote, and these are lines, like I said, that our graph will approach but never touch. So what we're going to do is we're going to evaluate, or we're going to choose x's on one side of 2 and on the other side of 2. And we'll plot those ordered pairs. So let's work from left to right. We'll approach 2 from the left-hand side, or we're going to evaluate for x's less than 2 and plot those ordered pairs. So I've got some tables set up that already have some of the answers. But let's go down and let's take a look at our graph. We'll work with this graph here on the left-hand side. F of x equals x over x minus 2. That's our function, and we have already determined that x cannot equal 2. That's our vertical asymptote. So I am going to sketch in our vertical asymptote here at x equals 2. Okay? So we will do that. So that is our vertical asymptote at x equals 2. And I'm going to bounce back and forth here a little bit. So let's go back up to our table of values and let's plot points. Like I said, we're going to approach x from the left-hand side. So that means we're going to approach x, or approach our asymptote from the left-hand side. So we're going to choose x's. Maybe we'll start out here at -4 or 5, and we'll get closer and closer and closer and closer to this vertical asymptote, and we'll see what happens to our output. And then we'll repeat that process, but we'll come from the right-hand side and approach, get closer and closer to 2. So we'll count our way down and see what happens to our graph. So let's go back up, and you can see here we're going to input -2 for x, and that's just -2 over -2 minus 2, which simplifies to -2 over -4, or 1/2. So that creates the ordered pair -2, 1/2. So we'll go ahead and plot that ordered pair. So I started out here at -2, and when I input -2, I output 1/2. So that's going to be about that point right there. And when I input -1, I have x is -1 over -1 minus 1. So when I input -1, oh, pardon me. Helps if I use my function. It's x minus 2, not x minus 1. So x is -1, so I get -1 over -3, which is 1/3. So when I input -1, I output 1/3. So my ordered pair is -1, 1/3. And when I input 0, well, that's easy. I don't even care about the denominator. If my numerator is 0, my fraction's 0, so my output's 0. So that's the ordered pair 0, 0, that's the origin. When I input 1, I output 1 minus 2. So I get 1 over negative 1. So when I input 1, I output negative 1. And the ordered pair 1, negative 1. And much to my chagrin, we're going to use fractions here. So 1.5 minus 2, which gives us an output of negative 3. And so on. We would put 1.9 in. We put 1.9 minus 2. Well, that's 1.9 over negative 0.1, or 1/10, so that's negative 19. 1.99 over 1.99 minus 2, that's 0.01, pardon me, that's 1.99, all divided by .01, negative 0.01, and I get negative 199 over 1/100. So let's take a look at what's happening to our graph. Let's go ahead and plot our points. Negative 1, 1/3, 0, 0. So negative 1, 1/3, that'd be about there. 0, 0. What else were our points? 1, negative 1. So that'd be right there. And then we had 1.5, negative 3. So that'd be about right there. So there's something going on here. As you saw, as we got closer and closer, we got negative 19. And so our graph is looking something like this. And we might even want to choose a value that's further out this way. But our graph is going to kind of head in that direction. And now let's take a look at x's approaching from right to left. So we're going to approach our graph from the right, and we're going to work our way this way and see what happens. We're going to close in on our asymptote and see what our behavior is. So I'm choosing 6 over 6 minus 2, which is 6 over 4, or 3/2. 5 over 5 minus 2, which is 5/3. 4 over 4 minus 2, which is 2. 3 over 3 minus 2, which is 3. And now we're going to get closer and closer. So 2.5 over 2.5 minus 2, which is, if you will, it's the fraction 5/2 divided by the fraction 1/2, which is the same thing as 5/2 times 2 over 1. Sure enough, that's 5. And 2.1 over 2.1 minus 2 is 21. And 2.01 over 2.01 minus 2, which is what? 2.01 divided by 0.01, which is 201. So this thing, the output, the y's keep going up, up, up as I get closer to inputting 2. My y's, my outputs get higher and higher and higher. Let's take a look at that. So 6 3/2. So 3, 4, 5, 6. When I input 5, I output 5/3. When I input 4, I output 2. When I input 3, I output 3. When I input 2.5, now I'm getting closer and closer to 2, I output 5. And apparently my graph looks something like that. So it's going to approach my asymptote, and as it gets closer and closer, it's going to shoot up, 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 and go to positive infinity. Let's take a look at another function, f of x equals x minus 1 over x plus 1. Hopefully you can see here that x can't equal negative 1. So I create a vertical asymptote at negative 1. Well, let's take a look at the behavior from the left and the behavior from the right and see what happens. I'm going to leave much of this for you to do on your own. Tell me what happens with f of negative 4 and f of negative 3 and f of negative 2. Well, f of negative 4 is negative 4 minus 1 over negative 4 plus 1, which is negative 5 over negative 3, which is 5/3. So when I input negative 4, I output 1 2/3. So something about right there. And so on and so forth. And then as you get closer to negative 1, you might have to look at negative 1.5 as an input and negative 1.1 as an input and see what you get for your outputs. So tell me what this graph looks like as it approaches negative 1 from the left-hand side. But then I want you to do the same thing from the right-hand side. I want you to choose x's out here and see what happens to your graph. So choose values like, well, let's do f of 4, and then do f of 3, and f of 2, and f of 1, and f of 0. I'll tell you that one right now. That's going to be negative 1. So I'm going to plot that point. But we still need to see what happens as we get closer and closer to x. What are our inputs here? Okay? And I think we're going to have another point right here too. So let's see what happens. What's going to happen? So I want you to do f of negative 1/2 or f of negative 0.9 and tell me what your outputs are. And bring that completed graph to class. So there's your introduction to graphing rational functions, and we will see you in class.